Hello and welcome to Coding Physics with Spreadsheets. If you are new to physics, you are probably learning that physics, there's a lot of numerical stuff to keep track of. There's a lot of variables with different names. There's a lot of numerical values to have to keep track of. And then they want you to go back and they want you to redo the problem with different numbers and all this stuff. You're also probably discovering that your physics class is kind of pushing your calculator to the limits. If you've got a simple non-graphing calculator, it's definitely being pushed to the limits, but even a graphing calculator can get a little bit overtaxed in a physics class. And there's really no reason to be limiting yourself to a calculator like that when there are lots of online coding tools available. You're also probably hearing about this term coding in the news and about how it's important for your career and it's an important skill to learn, etc. But really, you can start learning to code and learning to code in a physics environment just by using a spreadsheet. So what I have here on the screen is a blank Google Sheet that I will make available at a link in the description below. So you can open that link, follow along, make a copy of the spreadsheet to your own Google Drive folder, and just follow along as we learn how to do some simple coding practices in spreadsheets. Spreadsheets are actually a great environment to learn to code because you can see everything that's going on. With your calculator, you only see what you put in, what you got out, and you have to scroll back up on the screen to see what you did. But here, everything that the spreadsheet knows, everything that the computer knows, is here before you in this sheet, in this little grid. So let's start out, just in this episode, let's start out talking about how to use a spreadsheet as a calculator. Let's say, for example, you've been asked to calculate density. If I can spell density, there we go. I can calculate a whole lot better than I can spell it. The way you calculate density is mass divided by volume. So all I'm doing right now is putting in some labels. So I'm using my arrow keys on my keyboard to highlight each of these cells, and I'm just typing in a name. So here I typed in density, mass, volume. And you can go to the right by pushing tab, you can go down by pressing enter, or you can simply navigate around with the arrow keys on your keyboard. Doesn't really matter which. And you notice whatever cell is highlighted, whatever's highlighted in blue appears up here in the formula bar. I'm going to expand this a little bit just so we can see a little bit better. Up here is the formula bar. This is where we'll be doing the actual calculations. And in here is where we'll be seeing what the results are. So density is mass divided by volume. That means we need a value for the mass and a value for the volume. So let's suppose you had let's say you were working with a cinder block. Now Google tells me that a typical cinder block is right about 13.5 kilograms. Now I'm going to type in the 13.5. I'm not going to type in the kilograms. And that's where your physics teacher might get a little bit fussy because you're supposed to put units on everything. You can keep track of the units up here with just a couple of parentheses. So we have mass in kilograms is 13.5. Now Google tells me that the volume of a cinder block is about 16,000 cubic centimeters. Again, we'll keep track of our units up here on our label. We'll just say cubic centimeters, centimeters cubed. There we go. And so I've just entered in numbers here, right? I haven't done any math yet. I haven't done any calculations yet, but this is actually the key to getting the spreadsheet to work as a calculator, is to enter all the numbers that you need. Here's the thing. This spreadsheet goes on forever, right? If I hit Control right, I end up at Z. And you say, well, Z isn't very much forever. Right. Well, right click on this, and then you can do Insert One Right. You can get as many rows and columns as you want. So there's really no reason to not go ahead and enter all of the information that you have, even if it's information you're not going to need, right? So all I've done is entered my information so far. What that means is that the spreadsheet remembers 13.5 stored in this cell, and it remembers 16,000 stored in this cell, right? And so this cell is called B2. It's called B2 because it's in column B, row 2. This cell is called C2. It's in column C, row 2. So if I want to calculate the density, I can have the spreadsheet do that for me. All I need to do, anytime you want to make a calculation, is start with an equal sign. And my students forget this all the time. It's okay if you do, because when you forget it and it doesn't give you a number, you just go back, put an equal sign at the beginning, right? It's wonderful. Coding is wonderful because you get to go back and fix any mistake you made. You can go back and fix, right? So here we've got equals, and now I want to take the mass divided by the volume. Now, the way you would do this in a calculator would be to say, okay, I'll take 13.5 and divide by 16, 1, 2, 3 zeros, right? You would do that, and you would press enter, and it would give you the answer, right? And that would be the correct answer. But here's the thing. The spreadsheet already knows what these values are, right? Because when you come back and you need to do another problem with a denser cinder block that's 15 kilograms, and I have to go back and change this to a 15, and then I need to do another cinder block that's got a density of 20, I have to keep going back and changing that number here in the density. Instead of doing that, let me delete this. Instead of putting in those numbers, we can put in the cell addresses. What I'm going to do is I'm going to say equals, and then I'm going to put in a cell address. I'm going to put in B2. When I put in B2, you notice that B2 turns orange and cell B2 turns orange. That color coding tells me that this address, this B2, is referencing this number. Let's see what happens when I press enter now. You notice that it's 13.5. It's going to match whatever is in B2. Now watch what happens when I change B2. Let's suppose I change this to a 15. The A2 automatically changed to a 15. I didn't have to change this, right? It's still equal to B2. The actual thing that's in that cell hasn't changed. It's just that the numerical result has changed. All right, let's go back to 13.5 so that we can have the correct answer. So I've got B2, and now I need to divide by the thing in C2. So I'm going to say divide. It's just a slash, just like it is on your calculator. And now I could type out C2, but let me show you another trick. I'm going to go over to C2, and I'm going to click on it. I'm sure you could hear my mouse click on the microphone there, but I clicked on it. So I've clicked on it, and now I've got C2. It just popped up here. I didn't have to type it. It just popped up. And that's where spreadsheets are a really great computational coding calculator environment, because you can just click on the things you need. You don't have to remember what the cell address is. You can just click on those. So now I've got 13.5 divided by 16,000. I've got B2 divided by C2, and that gives me a 0.0008, just like I had before. Which is pretty cool, right? Because this is telling me this is my density in kilograms per cubic centimeter. There we go. And so this is pretty cool because now I can change either of these values, right? Let's suppose I have a more massive cinder block. Notice I press enter on that, this automatically changes. All right, let's suppose I increase the volume here, 20,000. This automatically changes. The beautiful thing about a spreadsheet and about coding in general is you only have to enter the formula once. Once I've entered the formula, I can just change these two values however much I want, and this number will automatically change to give me the answer. It might not seem like much, but think about how much time you spend on your calculator entering the same equation over and over again, just with different numbers. This is going to save you that time. It's going to save you time. It's going to save you brain power, which you can then use to actually do the physics, right? Because the entering this thing into the calculator is not the physics, right? The physics is understanding what density does, and that's what you need to spend your brain power on. We can do more formulas, right? Let's suppose that we want to work with circles, right? How do you describe a circle? Well, first you give its radius, right? Once you have a circle's radius, you can calculate its diameter. And you can calculate its circumference, and you can calculate its area, right? So let's do this. Let's suppose we put in a circle. Let's make a circle of radius a half, right? And let's be good about this, and let's make this half a meter. So this is going to be in meters, so this is going to be in meters, and area is going to be in meters squared. There we go. Oops, excuse me. There we go. By the way, if you make a mistake like that, you need to edit it. You need to edit the cell. All you do is press the F2 key, and it will bring you in here, and you can start editing the thing that you wrote. Now, you notice my circumference meters got cut off here. I'm just going to go up here to the border between these two columns, where I get this little double arrow. I'm going to click and drag, and that makes this thing wider. So isn't that nice? All right, let's suppose I want to calculate diameter. You know how to get diameter from a radius, right? It's equal to, right? Just say that every time you're calculating something, and you won't forget to put the equal sign. Diameter is 2 times radius. All right, so I just go over here, click on this, and I press enter. So here I've got a radius of a half, so I have a diameter of 1. 2 times a half is 1. All right, what if I make it a quarter of a meter radius? Well, boom, now I have a half a meter diameter. It changes automatically, just like this thing changed automatically for the mass and the volume. Now suppose I have the circumference here, right? So circumference is equal to 2 times pi times r. Now you got a couple options here for pi. You can either put in 3.14, 159, however many digits you want to go out to, or, and here we'll get into this a little bit more later, I can just type in pi. I believe pi needs an open parentheses, close parentheses, because it is technically defined as a function, so it's pi, open, close. But that right there gives you 2 pi. There's all the digits you could possibly want. We'll talk about significant digits in a second. But this needs to be 2 times pi times the radius here. So I've got 2 pi r there. I press enter. And there I've got my radius, which actually is pi because the 2 is canceling the half there. But let's suppose I had, again, let's go back to a 1/4 meter of radius. Watch both these cells now. With one press of an enter key, both of these numbers change. So you never have to enter the circumference formula into a calculator again. You can just use your handy spreadsheet and it'll automatically propagate that change forward in these two cells. All right, same thing with the area here. We need to have pi times the radius squared. The way you get a square or any power is just use the caret. That's shift 6 on a keyboard. So we'll do a5 squared. And there's my radius. So I can put in there's my area. So I can put in whatever radius I want here, and I will get out my diameter, my circumference, and my area all to my liking. Now here's the thing, right? You're in a physics class, I assume, if you're watching this coding for physics video. This is way too many significant digits, right? There is no way you're going to measure circumference down here. I know in high school they make a big deal about significant digits and they make you memorize all these rules and things. Here's the shorter way to think about significant digits. Follow the rules that your teacher gives you, definitely. But when it comes to significant digits, you need to think in terms of what could I actually measure, right? If I'm measuring my radius to be 1 meter, and I'm using a meter stick, there is no way on earth I'm going to use that same meter stick, or meter ruler for those of you across the pond. There is no way I'm going to use that meter stick, meter long ruler to measure out to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places, right? That's a nanometer. That's the size of an atom, right? You cannot measure atoms with a meter stick. So that's why we enforce these rules about significant digits, because it's ridiculous to claim that you can measure out that far. Now, spreadsheets are wonderful. They do not know how significant digits work, but you can decrease the number of decimal places. Just go over here where it says decrease decimal places. Click on that a few times. Usually, I mean, there's all these rules for significant digits. You should definitely follow them, but usually 2 decimal places is fine. There's really no reason to go beyond that, right? Okay, what else do you learn in a physics class? Oh, you learn about distance, velocity, and time, right? So let's actually put that backwards a little bit here. Let's say you start with time, right? Because time is a thing that moves forward no matter what. Let's suppose you have your velocity, and you want to know what your distance traveled is, right? So let's suppose you're moving forward by 1 second, right? So let's make this thing 1 second. We'll make our velocity in meters per second. Let's see, how fast do you want to be moving? Well, 1 meter per second is about walking speed. So let's say you're moving at a speed of 1 meter per second. You want to figure out how much distance you traveled in that 1 second during that moving at 1 meter per second. Well, distance is equal to, again, you always want an equal sign, the velocity times the time. And you have an idea of how to do this by now, right? You just click on these cells to get their addresses in here. You put the multiplication sign in between there, and we've come to the dramatic conclusion that 1 times 1 equals 1. Great. But here's the thing, right? I can change these numbers now, right? I could say, let's suppose I wanted to look at a smaller increment of time. Let's suppose I wanted to look at 1/10 of a second, right? I'm going to get out 1/10 of a meter, right? Let's suppose I wanted to change my velocity, though. Let's suppose I was moving a little bit faster at 1.5 meters per second. Okay, there's my 0.15. Here's the beautiful thing that I can do. I can take this equation and I can use it over and over again, right? Because time kind of marches forward, right? You don't just have a single time value in a problem. You keep the time moving forward. So let's suppose I go to a time of 0.2, a time of 0.3, a time of 0.4, right? So it's like I'm watching the stopwatch tick forward 1/10 of a second at a time. that would be really difficult to type out all the way up to 1 second or 10 seconds. Here's what you can do though. You can click and drag over this. Once you have a pattern established, right, you have go up by 0.1, go up by 0.1, go up by 0.1. You can click and drag over those. So I've highlighted all of these. Then you grab this little square in the center here. This is called the fill handle. This is one of the most important features of spreadsheets that you need to learn how to use. When you click and drag this, it's going to continue that pattern. There you go. 5, 6, 7, 8, 9, 10, all the way up to 1 there. And I can keep going, right? I can go up to 1.5. I can go even farther. I can go to 2 here, right? And here what I can do, let's get my velocity copied down this way. Notice I don't have a pattern here, so when I use the fill handle, it's just going to copy down the 1.5. And notice what I can do here is I can use the same fill handle. Now watch what happens with the fill handle here. I'm going to click and drag this down, and notice it went from a 0.15 to a 0.3. The reason it did that is because in this cell, in C7, it's calculating B7 times A7. When I use the fill handle, it moves the cells in the formula. Notice in this new one, it's B8 times A8. Whenever I do this fill handle, it's using what we call a relative position, meaning I'm taking the fill handle down and I'm saying, okay, take the thing to the left and multiply it by the thing 2 cells to the left. Right, so here I've got a 0.45 because I'm multiplying the cell to the left times the cell times the number 2 cells to the left, right? And I can keep doing that all the way down. See, I can come all the way down here. Again, multiply the cell to the left times 2 cells to the left. I can do that as far down as I would like, which is pretty cool because this means I can have any time value. Let's say you're doing an experiment and you need to be able to compare it to the calculation here. You can just set up all these time values, just use the fill handle. You only have to enter the equation once, and that fill handle fills all the rest in. That becomes really useful because now I can make a graph of this thing. So what I'm going to do, I'm going to use my shift button to select this region of data. I'm going to skip over the velocity, and I'm going to press my control key. And now I'm going to hold down control and shift to get all of this. So I've got 2 regions of data selected here. So again, I use shift to get all this, and then use control shift to get all this. What I can do now, I can go insert, chart. And so here I've got this wonderful graph showing me my position versus time. You notice I get a nice steady increase in my position versus time because my velocity was constant. What we're going to play around with later is what happens when you change a velocity. So let's suppose I get a sudden gust of wind and at this moment I move 2 meters per second. You notice I get a little bit of a jump there. We'll come back to how that should work out a little bit later. But yeah, so this is an example of what you can do with spreadsheets in a physics class. You can use it as a calculator. You can use it as a graphing tool. I mean, this can really replace your graphing calculator. You don't have to wrestle with that thing anymore. All right, next time we're going to take a deeper look at how this velocity business works and how we can use this graph to predict what's going to happen with something moving. So thank you so much for watching. I will see you next time. Bye-bye.